Hello, welcome to this class. Last time I told you that we are going to move into another concept, which is factors and multiples of a number. But lastly, we concluded our lesson on approximation and estimation of numbers, which ended with rounding numbers to significant figures. So today we are moving into a new topic, factors and multiples of a number. They always go hand in hand because they are like words and opposites. Okay? When we talk about factors, we are talking about division. When we talk about multiples, we are talking about multiplication, even as the name implies. Multiples, multiplication, multiply. That's why I said that they are like words and opposites. So, what are factors? You may ask. Factors are simply a number that can divide another number without a remainder. We said that the number that can divide another number is a factor of that number it divides. For example, we all know that 6 divided by 3 will give us 2, right? Therefore, 3 is a factor of 6. Why? Because 3 can divide 6 without a remainder. Suppose we have a number like this, 6 divided by 4. Can 4 divide 6 without a remainder? No, because 6 divided by 4 will be 1 remainder, 2. Therefore, 4 is not a factor of 6. So, factors are numbers that can divide another number without a remainder. So I can say, suppose, suppose y can divide, okay, suppose y divided divided by x is z. Suppose y divided by x is z, then we can say that x is a factor of y. In other words, I mean, if y divided by x equal to z, then x is a factor of y. Alright? So, whenever a number, our x, y, z are simply representing numbers, they are variables representing numbers. So, if x can divide y to give us z, then x is a factor of y, not z. But, okay, let me use this as an example. We also know that 6 divided by 2 is 3. So what is this telling us? That 3 is a factor of 6, 2 is also a factor of 6. Alright? 3 is a factor of 6, 2 is also a factor of 6. Because when you get the quotient of a number as a result of division, it can still give you another number. Okay, let's check this. 22 divided by 11 is 2. 22 divided by 2 is 11. So you can see that 11 and 2 are both factors of 22. They are both what? Factors of 22. So simply put, the factors of a number are all the numbers that can divide one number without a remainder. Okay, let's take for example. Let's take for example. Say find find the factors of 12, 24, and 20. The question asks us to find the factors of 12, factors of 24, factors of 20. So, what does this thing mean? It means that we should find all the numbers that can divide 12, all the numbers that can divide 24, all the numbers that can divide 20. Okay? Now, one thing to note is that 1 is a factor of every number, and every number is a factor of itself. 1 is a factor of 13, 13 is a factor of 13. Because a number can divide itself. 2 divide 2 is 1. 3 divide 3 is 1. 12 divide 12 is 1. 100 divide 100 is 1. So 1 and 100 are factors of 100. Therefore, 1 is a factor of all numbers, and every number is a factor of itself. Okay? So, let's look for factors of 12. So we need to find all the numbers that can divide 12 without a remainder. So 1 can go, 12 is even, therefore 2 can go, 3 can go, because 3 times 4 is 12, therefore 4 can also go, 6 can go, and 12. Now, one of the tricks that is that we can notice when listing, okay, before I say that, let's find the factors of 24 and the factors of 20. Then I'll say what I want to say. 1 is a factor of 24, 2 is a factor of 24, 3 is a factor of 24, 4 is a factor of 24, 6 is a factor of 24, 12 is a factor of 24, and 24 is a factor of 24. Let's look at factors of 20. 1 is a factor of 20, 2 is a factor of 20, 5 is a, okay, I jumped 4. 4 is a factor of 20, 5 is a factor of 20, 10 is a factor of 20, and 20 is a factor of 20. So all these numbers listed here are factors of 12, 24, and 20. These are factors of 12, these are factors of 24, these are factors of 20. Alright? Now, I wanted to say something. Whenever you are listing the factors of a number and you get to the middle of the number, like half of the number you are looking for its factors, then the next factor becomes the number itself. You can notice at 12, once we got to 6 as a factor of 12, 6 is half of 12. Half of 12 is 6, right? Since we have gotten to half of the number, then the next factor becomes the number itself. Also, you can notice that in 24, as we got to 12, 12 is the half of 24, and the next factor becomes 24. The same thing with 20. 10 is the half of 20. Therefore, the next factor is 20. So, factors of numbers simply means all the numbers that can divide that one single number without any remainder. So whenever you are asked to find the factors of a number, the question is simply asking you to list out every number that can divide that particular number without a remainder. And all the numbers that can divide that number without a remainder are called the factors of that number. Now, in factors, we can now look at two things. We can now look at the concept of prime numbers, prime factors, and composite numbers. All right? Prime numbers and composite numbers. But under prime numbers, we bring out prime factors immediately. Okay? So let's look at this. Let's consider that prime and composite numbers. Prime and composite numbers. Now, the first question here is, what is a prime factor? The second question is, what is a composite number? What is a prime number? What is a composite number? Now, a prime number is a number that has only two, that can be divided by 1 and itself, meaning it has only two factors. All prime numbers have only two factors, 1 and itself. A prime number is a number that can only be divided by 1 and itself. So when you look at all the numbers that can be divided by 1 and itself, only all those numbers are called what? Prime numbers. So I can say here that a prime number is a number that can only be divided by 1. Okay, let me write this in letters. By 1 and itself. Prime numbers are numbers that can only be divided by 1 and itself. Examples are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and so on and so forth. All these listed are what? Prime numbers. Now, if you notice, there is no 1 there. The question now is 1 a prime number? Is 1 a prime number? What do you think? No, right? At least I didn't list it as examples of prime numbers. But why? Why is 1 not a prime number? 1 is not a prime number. So the answer is no. Why? The definition for prime number says that a prime number is a number that can be divided by 1 and itself. In other words, prime numbers has two factors. Prime numbers has two factors, which are 1 and the number itself. But 1 has only one factor. 1 can only be divided by 1. It has no other factor except 1, which now failed the definition of prime numbers. Because the definition says that every prime number has two factors, but 1 has only one factor. So 1 is not a prime number. This is the reason why 1 is not a prime number. But the thing to note here is that every number can be divided by 1, meaning that 1 is a factor of every number, including itself. But 1 is not a prime factor. It's not a prime number, rather. Now, so let me talk about prime factors immediately. Now, prime factors. Before I go over to composite numbers, prime factors Now, I know you might be asking yourself, prime numbers and prime factors, are they not the same thing? They are not. Prime numbers are numbers that has two factors. But prime factors is now a prime number that is a factor of another number. A prime number that is a factor of another number is called a prime factor. Okay? But all prime factors are prime numbers. But not all prime numbers are prime factors of a number. Let me take for instance the number 12. Let's go. 2 is a prime number. If you divide 12, it is 6. 12 can also be divided by 3 to give me 4. Is there another thing? No. From here, no other number. Now, 2, which is a prime number, is now a prime factor of 12. 3, which is a prime number, is now called a prime factor of 12. Why? Because they can divide 12 without a number, a remainder. But does it mean that 5 can divide 12? 5 divided 12 is what? 2 remainder 2. Are you seeing it? 5 is a prime number, but it is not a prime factor of 12. That's why I said that prime numbers and prime factors are different. Prime numbers are every number that can be divided by one on itself. But prime factors are now prime numbers that can divide another number without a remainder. Or prime factors are prime numbers that are factors of a number. Okay? So we can say here that prime factors are prime numbers that are factors of a number. So you can now see that since 2 and 3 can divide 12 without the remainder, therefore 2 and 3 are prime factors of 12. Okay, let me just write it. Example, 2 and 3 are prime numbers and also factors of 12, therefore 2 and 3 are prime factors of 12. Okay? Okay? So that is the thing there. Alright? All prime numbers are not prime factors of a number. Remember, I'm not saying that all prime numbers don't have a number that they can divide. But when we have a single number in consideration, that number can have some prime numbers that are factors of it. But not all prime numbers are factors of that particular number you are considering. Okay? Alright, then let's talk about composite numbers. Now, all numbers that are not prime numbers are composite numbers. All numbers that are not prime numbers are composite numbers. So what does this mean? If prime numbers has 2 factors, now every other number that has more than 2 factors are composite numbers. 6. The factors of 6 are 1, 2, 3, and 6. How many numbers are here? How many factors are here? 1, 2, 3, 4. Therefore, 6 is a composite number. But the number 5 has only 2 factors, 1 and 5. 5 is a prime number, 6 is a composite number. So composite numbers are numbers that have more than 2 factors. Composite numbers are numbers that have more than two factors. All right? So let's go. Composite numbers. These these are numbers. These are numbers that has or have more than two factors. Example, all numbers that are not prime numbers are composite numbers. Okay? 6, 12, even 4, even 9, and so on and so forth. All these are composite numbers because the factors of 2, 6 we've listed, the factors of 12 you can see it, the factors of 12 are 1, 2, 3, 4, 5, 6. 12 have 6 factors, do you see? So it is not a prime number, but it's a composite number. The factors of 4, which you know are 1, 2, and 4, 3 factors, right? So 4 is a composite number. The factors of 9 are 1, 3, and 9. Now you see, this is a composite number, not a prime number. Okay, so the difference between prime numbers and composite numbers is the number of factors they have. The number of factors they have is the difference between the composite numbers and the prime numbers. Okay? Good. Alright, let's now talk about multiples. All these things we've been talking about since are all about factors. Factors, prime factors, composite numbers, prime numbers, all of them we've just been talking about factors. It's an introduction class. Okay? We want to talk about factors in details. Same thing, we have to talk about multiples in details also. Alright? Now, at the beginning of the class, I said that whenever we talk about factors, it is associated to division. Whenever we talk about multiples, it's associated to multiplication. As the name also implies, multiples, multiplication, multiply. All of them are synonymous. Now, we are now talking about multiples of a number. Now, the multiples of a number is simply a number gotten as a result of multiplying two numbers together. When you multiply two numbers together, what you get is the multiple of the two numbers you multiplied. For example, okay, let me clean here. Now, you notice that 4 times 5 equals 20. Is it not? 4 times 5 is 20, right? Now, 20 is a multiple of 4 and 5. 20 is a multiple of 4 and 5. Okay? Good. But here, let's link multiples and factors together. Let's link them. Remember that in multiplication and division, we said that 12 divided by 4 equals to 3. That's what division says. Okay? Then we have what we called Inverse. Inverse of multiplication. We have what we call inverse of multiplication, which now shows that if 4 times 3 equal to what? 12. This implies that 12 divided by 4 is 3. Okay? If 4 times 3 is 12, then the inverse of it shows us that when we divide 12 by 4, we will get 3. Or when we divide 12 by 3, we will get 4. So, since 4 times 5 is 20, 4 and 5 are also factors of 20. Okay? Okay? Since 4 times 5 is 20, what it simply means that 20 can be divided by 4, 20 can be divided by 5. 20 by 4 is 5, 20 by 5 is 4. Therefore, 5 and 4 are factors of 20, while 20 is a multiple of 4. 20 is also a multiple of 5. Okay? So the multiples of a number is obtained by multiplying two numbers together. When two numbers are multiplied together, what you get, which will always call product, the product of those two numbers is called the factor. Sorry, is called the multiple of the two numbers that was multiplied. Alright? So the multiples of a number x and y is that number you get as a result of multiplying x and y. Hope you are following. Hope you are following. Good. So when we talk about multiples of a number, we are simply looking for a number gotten as a result of multiplying two numbers together. Okay. Now, how do we get the multiples of a number? Suppose I said list the multiples of 4. It is simple, very simple. The multiples of 4 are obtained by using the multiplication table or by skip counting. Both ways are still multiplication. Okay? To obtain the multiples of 4, you simply use your multiplication table of 4, or you simply use your skip count in 4s. Okay? So the multiples of 4 here by skip counting, let's go. 4, 8, 12, 16, 20, 24, 28, 32. All these are what? Multiples of 4. Because 4 times 1 is 4. Remember I told you that a multiple of a number is obtained as a result of multiplying that number with another number. Multiplication of two numbers gives us the multiple. 4 times 2 is 8. 4 is multiple of 4. 8 is multiple of 4. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And so on and so forth. Alright? So the multiples of a number is obtained by either skip counting in the numbers or using the multiplication table in that number, of that particular number. Okay? Okay? Okay, let me write down a few things. The multiple of a number let's say 2 and 5 is the product of 2 and 5. Yes. The multiple of a number, let's say 2 and 5, is the product of 2 and 5. Therefore, 2 times 5 equals 10. Right? So therefore here, 10 is a multiple of 2. 10 is a multiple of 5 also. Alright? Alright? Multiples of a number can be obtained by skip counting. Multiples of a number can be obtained by skip counting in that number. Examples. Find the multiples of 5 and 6. Solution. Multiples of 5 are. Now, the question says that we should find the multiples of 5 and 6, and like I said, the multiples of 5 are those numbers gotten by skip counting in 5s. Alright? Or you make use of your multiplication table, the 5 multiplication table. 5 times 1, 5, 5 times 2, 10. Now 5, 10 are multiples of 5. Okay? So the multiples of 5 here I have 5, 10, 15, 20, 25, 30, 35, and so on. While the multiples of 6, we now skip count in 6. So we go 6, 12, 18, 24, 30, 36, 42, and so on. Now, one thing to note is that the multiples of a number is unlimited. The multiples of a number is unlimited. It keeps on going like that, like that, like that, and like that. Okay? Alright. So I think we will stop here. This is just introducing what multiples of numbers, what factors of numbers, what prime factors of numbers, what composite numbers are. Okay? Now, in the next class, we will now look at the calculations that comes with factors and multiples of a number. Then we will look at finding the product of prime factors of a number. We look at finding the lowest common multiples of a number, finding the highest common multiples of a number. Then we keep on going like that till we get very conversant with multiples and factors of a number. So I'll see you in our next class.